Chapter 1, Section 6, Part 2. Okay, we've already dealt with absolute value equations. Now we're going to deal with absolute value inequalities. We're going to go ahead and solve absolute value inequalities. Okay, just a reminder, remember, when we're talking about inequalities, we mean everything except for the equal sign. We're talking about greater than, less than, equal to, greater than, equal to, or not equal to. Remember to flip the sign when you multiply or divide by a negative number. Okay, when you solve absolute value inequalities, you're going to be flipping the sign almost every time. So you need to make sure and pay attention when you multiply or divide by a negative number. Okay, and then everything else you're going to pretend the inequality sign is an equal sign, and you're going to solve the equations like you, or solve the inequalities just like you would in an equation. Here are the steps to how to solve an absolute value inequality. Now, I'm going to read these to you. If you need to pause the video and go ahead and write down the steps, I would recommend that you write these steps down. These are very important, and if you ever have an inequality that you are unable to solve, you can come back, go through step 1, go through step 2, go through step 3, and so forth, and try to solve the inequality. These are really going to help you. Step 1, you need to isolate the absolute value. Okay, just like we did when we solved absolute value equations, we also need to do when we solve absolute value inequalities. Get rid of the addition, subtraction, multiplication, and division before and after the absolute value. Okay, that's the stuff that's attached to it that is not inside the actual absolute value. Get rid of it. Isolate that absolute value. Step 2. Determine if the absolute value is even possible. Okay, remember when we did absolute value equations when we got a negative answer? When we isolated, for instance, the absolute value of 3x minus 4 equals negative 3, that's not even possible because you can't have an absolute value with negative. So before you even go ahead and do a bunch of work, determine if it's even possible, okay, to solve the inequality. Step 3, do your two cases. Case 1, the positive case, like you did in the equation. Case 2, the negative case. Solve each case. Do your number lines, or in other words, make your number line, graph it like you have before. And step number 6, find the final answer. All right, now that you have your steps, let's go to the next page. If you need to pause the video so you can get those notes, go right ahead. All right. 3 times the absolute value of y minus 9 is less than 27. Well, let's go back to our steps. Let's say, okay, step 1, isolate the absolute value. Well, what is attached to the absolute value here that we need to get rid of first? Correct, for 3. If we can divide both sides by 3, the absolute value is then isolated. So go ahead and do that. Since we're dividing by a positive number, we cannot need to switch the sign. So let's divide both sides by 3. We have the absolute value of y minus 9 is less than 27 divided by 3 is 9. Now, determine if the absolute value is even possible. Is there a chance there's no solution? No, there's no chance because this is a positive number. Okay, so we need our two cases. Okay, we need our two cases, case 1 and case 2. Case 1, y minus 9 is less than 9. And case 2, negative y minus 9 is less than 9. Now we need to solve both sides. Step 4, solve each case. I'm going to add 9. And I have y is less than 18. Now, for the second case, you can do one of two things. You can either distribute the negative like we did in the absolute value equations, or you can divide both sides by -1. Okay, I'm going to go ahead and do that, and I'm going to tell you, what do you notice, or what do you have to remember when you divide by a negative? What must you do to your inequality symbol? Yeah, you have to flip the sign. So I'm going to go ahead and flip the sign. I'm going to say, okay, now this becomes -9, and I have this negative cancels out. So I'm left with y minus 9. Solve for y, I have to add 9 to both sides. What is, go ahead and scroll down here. What is -9 plus 9? -9 plus 9 is 0. So I have y is greater than 0. Go back to your list. Solve each case. Now create number lines. Do the number line. Graph each inequality and decide what your solution is. Okay. Go back to when you had and or solution. Okay. And we're going to have to use those and or solutions in order to decide what the solution is here. So I have case 1. Y is less than 18. So I'm going to go back here to 18 and I'm going to say, okay, y is less than 18, so it has to go this way. Okay, y is going to go that way. But y is also greater than 0. Okay, so here's 0, I have an open dot, and it's going to be greater than, okay, if you don't remember, put your variable on the left-hand side, which way the arrow points. Okay, this arrow is pointing this way, which that's why we want this way. This arrow is pointing this way, that's why we want this way. Okay, now, let me ask you this. What type of inequalities come together, and or inequalities? These are going to hit each other. They're going to run into each other. Is this an and or? My final solution, is it going to be an and or an or? An and, because it comes together. There are two different ways to write an and compound inequality. The solution to an absolute value inequality is always the compound inequality. Okay, you just have to decide which compound inequality it is. Is it an and, where the graph runs into each other, or is it an or, where it goes in the opposite direction? In this case, it's an and. So I can say, okay, y is less than 18, and y is greater than 0. Or if you want to write it the other way, okay, who remembers how we write and inequalities in one compound inequality without the and? You put y in the middle, put your bigger number over here, your smaller number over here, connect it with whatever they connect with. So either solution would be okay. I'm going to erase those so you don't think they're equal. Okay, but either solution would be okay as long as we know the solution to the absolute value inequality is always a compound inequality. You have to remember that. Think to yourself, if you can't understand that, make sure you ask me that question. What do you mean, Mrs. Numbers? Okay, let's try another one. This is the same one. Here we go. All right. Step 1, I'm going to go ahead and do this one without the steps beside me. If you guys need your steps, get your steps out that you had. Step 1, isolate the absolute value signs so that we can create a compound inequality where we have a case 1 and case 2. So the first thing I have to do here is subtract 2. Okay, so I have 1/4 times the absolute value of x minus 3 is less than -1. I still have the 1/4 attached to the absolute value. How do you get rid of a fraction? We've talked about this. How do you get rid of a fraction? You multiply by the reciprocal. So I'm going to go ahead and multiply both sides by 4/1. This one I don't have to write it as a fraction because we're not multiplying by a fraction. So I have -1 times 4 gives me -4. And these are going to cancel, so I'm left with the absolute value of x minus 3 less than -4. Okay, now go back to your steps. Once your absolute value is isolated, first, before you go making case 1 and case 2, check to see, is that absolute value inequality even possible? Can we put anything in there for that x so that it's going to be less than a -4? No. Because anything you put in that for this x right here, we're finding the absolute value of, meaning it always has to be positive. Well, is there any positive numbers that are less than -4? No, anything less than -4 is maybe 5, maybe 6, maybe 7, maybe 8. On and on is bigger and bigger negative numbers. So we're never going to have a solution to this equation, so we can just stop there. And we put no solution. Okay, that's not possible. There are no x's that work in this inequality. Let's move on to another one. Okay, first things first, isolate, step one, isolate the absolute value. So I'm going to add 3 to both sides. I'm going to have the absolute value of x plus 5 over 3 minus, or I'm sorry, is greater than 9, because 6 plus 3 is 9. Now, look at it. Is it even possible? Yeah, because I have positive numbers and 9 is a positive number, and we're talking about numbers that are greater than 9, 10, 11, 12. None of them are negative. Okay, so yes, this is definitely possible. So we're going to go ahead and create our 2 cases. Case 1, x plus 5 over 3 is greater than 9. Case 2, negative x plus 5 over 3 is greater than 9. Go ahead and solve each case like it were an equation, except there's an inequality somewhere. Okay, well, how do I get rid of dividing by 3? I multiply both sides by 3. Okay. These are going to cancel. I'm left with x plus 5 is greater than 27. Subtract 5. I have x is greater than. Okay. Now solve the other one. Remember when I told you if you want to get rid of this negative sign first, you do not have to distribute it? That's fine. Just divide both sides by -1. If it's on the outside of the parentheses, you can go ahead and do that. If we're inside the parentheses, then it would be a little more difficult. But since it's outside the parentheses, we can do that. These are going to cancel, and I'm left with x plus 5 over 3. Now, we are dividing by a negative number. What has to happen to the sign? We must flip the sign. It then becomes less than -9. Don't forget, if you divide by a negative number, you must flip the sign. Now go ahead and multiply both sides by 3. I'm going to have x plus 5 is less than -27. Subtract 5 from both sides. I have x is less than -32. So now we have to graph these and determine, is our solution, is this compound inequality an and or an or? Well, let's go ahead and graph it and find out. I have 2 inequalities. Okay, and here's 22. Here's -32. Graph the first one, x is greater than 22, so we're going to have an open dot, and we're going this way. Different colors so you guys can see that. Open dot, we're going this way. Okay, and on this one, x is less than -32, open dot, and we're going this way. So our arrows are going in opposite directions. What type of compound inequality is the solution to this inequality, this absolute value inequality? An or. We're going to have to write an or in the middle. So we say x is greater than 22, or x is less than -32. And that's our final solution. Any questions? Okay. That is, let's see if we have any, should be okay with that one. There is, not sure what your homework is. I will go ahead and put it on Edmodo. It may be this. These may be too many. So I'll go ahead and take a look.